Ever stop and wonder what everything around you is really made of? I mean, from the phone in your hand to the air you're breathing, it all comes down to the same tiny, invisible ingredients. So let's dive in and get to know the universe's ultimate building blocks.
Okay, let's start with a little riddle. You've got a heavy frying pan, a super light soda can, and the oxygen that keeps you alive. They couldn't be more different, right? Well, what if I told you they all share one incredible secret?
And there it is. That's the secret. They are all built from the same kind of thing. Unbelievably small particles that act like the foundation for, well, everything. The best way to think about these little particles is to picture them as Legos. You know, the tiny individual bricks you can use to build anything you can possibly imagine. This is the simplest, most basic level of everything that exists. Now, the official science-y name for these tiny Legos is atoms. An atom is the smallest possible piece of any pure substance, what we call an element. It's the point where you just can't break it down any smaller and still have it be the same stuff. To really get this, just imagine zooming way, way in on a solid bar of pure iron. What you'd see is just a huge organized stack of individual iron atoms, all packed together. Nothing else, just a giant collection of our single, identical Lego bricks. But here's the thing, atoms are pretty social. They rarely just hang out by themselves. Just like Legos, the real magic happens when they start connecting with each other to build bigger, more complicated things. And there are two main ways they do this. On the left, we've got molecules. Think of these as buddies, a couple of atoms of the same element holding hands, like two hydrogen atoms sticking together to make hydrogen gas. Then on the right, you've got compounds. These are more like full-on teams, where atoms of different elements join up, like when iron and oxygen atoms team up to make iron ore. And now for the really cool part. When these atoms decide to swap partners, break up their teams, or form new little buddy groups, well, we call that a chemical reaction. It's really just a big reshuffling of all the tiny building blocks. So here's a classic example. When you drop a piece of metal into some acid, this amazing swap starts to happen. The atoms rearrange themselves to create two brand new things, a type of salt and pure hydrogen gas. And you can actually see this happening. All that fizzing and bubbling you see, that's the new hydrogen gas being born. Every single one of those little bubbles is made of trillions of our hydrogen buddies escaping into the air. And it's not just acids. Some really energetic metals will even react with plain old water. The rule is pretty similar. The atoms do their shuffling thing, and once again, hydrogen gas is one of the new things that gets made. And just like before, you can see the proof with your own eyes. Those bubbles popping up in the water? Yep, you guessed it. That's more of our hydrogen molecule buddies being created, showing us that a chemical reaction is definitely happening. Okay, so we've got single atoms, buddy molecules, and team compounds. So what? Why does this even matter? Well, because understanding this is how we build our entire world, from a simple rock all the way up to a complex rocket. Here's a key thing to remember. You don't just find big chunks of pure iron lying around in nature. Out there, the iron atoms have already teamed up with oxygen atoms from the air. They're locked together in a compound, a team called iron oxide, which is just the reddish rock we call iron ore. So, how do we get the useful metal? Simple. We have to break up the team. We take that iron ore, we heat it up to insane temperatures in a huge blast furnace, and all that energy forces the iron and oxygen atoms to finally let go of each other. That lets us collect the pure single iron atoms, our basic building blocks, to use for whatever we want. And this whole idea, breaking atoms apart and putting them back together, is literally the foundation of our modern world. Let's just look at a few places these pure elements end up. Because we know how to separate atoms from their natural teams, we get pure aluminum for things like lightweight airplanes. We get pure copper for the wiring that powers our lives. And we get pure iron, which becomes the steel for our cars, our bridges, and our skyscrapers. It all starts with rearranging those tiny building blocks. So this leaves us with a final, really awesome thought. We've seen how we can get amazing things by breaking atom teams apart. But what happens when we start putting new teams together on purpose? What kinds of new materials, or medicines, or technologies could we create then? The possibilities, they're just endless. And that's our quick tour of the incredible world of atoms.